Everyone has been asking me if you use math a lot when it comes to welding.
Yes, we use math all day, every day, but don't worry, it's not really that scary because what is math? When people talk about being scared about math, I know I was afraid of math. I almost didn't graduate high school because of math, because I failed trig so many times. I wasn't allowed to walk. Almost didn't graduate high school because I had to go to summer school for math my senior year. But here I am. I wound up going to college for welding, and the instructors at the Pennsylvania College of Technology, and I'm assuming every other type of trade school or university, because I also went to Kutztown University, and their math instructors were pretty awesome. It's a whole different world when you start going to higher education for something that you really want to go for, because the quality of instructors there they're paid to go above and beyond. They're paid to have open office hours. It's part of their obligation as an instructor to have extra time for you, and they're so nice. I wound up almost minoring in math after having had it in college, just because everything made sense. And although math isn't a philosophy, math can really help you to make sense of the world. Think about it, you use math as soon as you wake up, you look at your phone, you see the time, you see those numerals, you see what time it is, you're measuring time. You go down, you put your
oatmeal in the microwave.
You're estimating how much heat you want to put into it or how much mascara is left in your tube. These are all estimations of measurement. We start by teaching kids math in kindergarten. I get to tutor the kindergartners, and guess what they're doing? They're learning to count, they're learning their numerals, they're learning relationships between sets of 10, and they're learning their shapes. And then you've got the big crazy theoretical stuff that I don't understand, like algebraic geometry, where you take geometric problems and you translate them into really abstract algebraic systems, and then stuff like set theory, where you're learning how systems affect other systems and infinity is in there somewhere. That's theoretical math, okay? There's theoretical and there's applied math. Theoretical math is when you're looking at those numerals and you play with them and you interact. It's more like systems. We're gonna talk about applied math, like what I mentioned before. It's this thing. This lives on my hip when I'm a fabricator, and this is math. You might be surprised how many dumb welders are really good at doing math down to a 64th of an inch, just because when you use it every day, it actually becomes second nature. If you can't tell by now, I'm using the term dumb welder lovingly. I should probably just stop using it, but I use it tongue in cheek because I believe that every tradesperson is as smart and valuable as someone who's got more of a cerebral. Like, the smart people in this world aren't just the ones who are academically gifted, although that's a part of it. Applied math isn't about looking at relationships and systems. It's actually grounded in the physical world. It's a grounded math. It's taking your tape measure out and measuring a piece of stock. It's looking at a rack of stock and estimating with your mind, do I have enough for 3 of these things I'm trying to build, or do I need to tell somebody to go make an order? It's bend allowances, it's loads on cranes, it's loads on beams, it's holding a square. If you're trying to put 4 pieces on a square, you could hold a square up against it, but a more clever way is to find your A squared and your B squared, calculating what C squared should be, and then from that you get your measurement, and then you go corner to corner. I use that triangle equation all of the time. And it's intuitive. It's not quite as abstract as like symbolic math. Like, okay, here. So my husband's really good with numbers, right? He's an accountant and a bookkeeper, but before that, he was also very good at organic chemistry, which is kind of an upper level chemistry class that you can take as a science when you're in college. For organic chemistry, you're manipulating numbers and they're representing like molecules and concentrations and probabilities and statistical analysis and error. But it's not intuitive. Like, you can't see it. You can see it. To me, it's a lot like accounting. Every number in these enormous spreadsheets, I got people in my family who are accountants, and they know everything that's going on, and they can attach a meaning and a reason to these numbers. They see that that is like payroll or taxes or accumulating interest, something going on with the money, the finances, the obligations behind all of those numbers. That kind of like, my eyes are already glazed over hearing myself say it. But you give me one of these, I'm pretty good with one of these. I'm pretty good with data sets. I'm pretty good with collection and sorting and then manipulating them to come up with a very usable answer. Grounded math is what farmers do all the time. And contractors, my God, I've got a real good contractor. We were talking about putting a set of steps in my house, and he just, off the top of his head, he started doing rise and run calculations for an L-shaped staircase into my attic and like trying to figure out if there was enough room for the door and the clear. I just stood back. I couldn't believe what he was doing without pen and paper. It's not that hard, and you just have to trust me. As long as you keep doing it, you get in with someone who's not going to make you feel dumb when you don't get the right answer. Fabricating math really isn't all that bad, and for the most part, when you're using fractions, you're using only these fractions like inch, half inch, quarter inch, eighth inch, 16th inch, 64th of an inch. You never know, you might wind up liking the trade so much that you wind up using one of these things, and they cut an inch way, way, way down. If you're a machinist, you're going to wind up using something like calipers or verniers. Looky here, here's some more measuring tools. We use these quite a bit. You just try to get the little bubble between the two lines and now you've got a horizontal surface. But when you start getting a little more involved into like hand railings where you have to hold, getting excited, I spilled my coffee. Like a hand railing on a platform where you have to go up X amount and then over and then up X amount and maybe a bunch of angles are divided out, you get to use one of these things. It's a digital level, but you have to make sure you've got your angles right. But again, a circle is 360 degrees. A line is 180, a right angle is 90 degrees. Those numbers repeat over and over and over and over and over, year after year as you do this. It's not like some abstract oddball thing is going to be thrown at you. It's not. It's this discrete amount of degrees in a circle that you've seen since you were in elementary school. Just learning how to use it in a practical sense in the real world. And please believe me, it is fun. From a former math hater to a fabricator, math hater to fabricator, it's not that bad. And I'm nowhere near as good as I could and probably should be, but I'm better than I used to be. And my relationship with math actually changed dramatically when I became a tradesperson. I think because I no longer saw it as pointless, if I'm being real. I saw math as being kind of pointless, like when are we ever going to use this? But when you graduate and you start building things and doing things, I also went to school for science where we did like population analysis, where we went out and measured plant leaves and stuff like that and analyzed diseases and stuff. And I could actually see like a graphical representation of information that I saw in the real world, but now I could take it and put it on a piece of paper and show it to somebody else. I have forgotten more than I remember. So yeah, do builders use the language of building while they're building things? Yes, we do. We use math all of the time. And the cool part is that sometimes when you learn it from someone who's really good, who's been there a while, they don't realize that they're doing math. There are a lot of you who follow me, you Gen Xers, I'm looking at you now. You have internalized your ability to do math because you know about like displacement and back pressure and resonance and all of these physics adjacent disciplines that are completely math related, and you just do it off the top of your head. You don't call it math. It is. You people invent geometry from incomplete information. You are able to extrapolate naturally, and that's a very real way of using applied arithmetic and spatial reasoning. Tolerances on a part are very important because if you have to build something 8 inches long, but it doesn't matter if it's a little bit short because it's going inside of something, but it cannot be longer, you've got an under tolerance, it cannot be over tolerance. So you have to be able to do a little bit of math, knowing that it can be a little bit too big because if it's too small, it's going to fall through a thing. You have to understand tolerances, plus or minus. Sometimes you've got a wiggle room of a 1/4 inch, meaning it could be an 1/8 inch this way or an 1/8 inch that way. That's very important math, holding to a tolerance. Very easy math, very critical math. And of course, if you want to be an engineer, if you want to be a designer, if you wind up really liking math and holding on to it and you understand the concepts behind it and then you understand how to put the numbers on the paper the way my accountant does and the way organic chemists do, now you've got like the super brain for applied math. And they're the ones who actually use those numbers to create new things and to draw the things. But as far as being a grunt welder, it's not that bad. As far as being the one in the shop to build things, you can either figure it out or look it up. I got my little cheaty books. I always kept these in my toolbox. They're just little references for the most common things you might need, or maybe you need only once a year. This is a great little print from Pacemaker Steel that tells you how to order I-beam. You ever wonder, like, if you need a tall, skinny I-beam with just a tiny little flange up top at the bottom, or maybe you need a really wide one? It breaks down how you can order the I-beam specifically. Here's how to sling up a load if you're using straps to carry something. This is just a handy little book to have. You got a phone, you can look most of this stuff up, but it's actually kind of fun reading once in a while. Roof pitches, rafter lengths, maximum floor joist spans, ASTM and SAE standards for threading and bolt heads. Decimal equivalents, those are huge. Drilling a hole, you want to know what size bit to put in, and especially if you're going to thread that hole, you're going to want to know which bit to run through first before you run your tap through. Glues and adhesives, motor wiring specs for a DC motor, all this receptacle shit is so handy. Yes, of course there's math. I've gone on at length about this, but it's not bad math. It is applied, grounded math that usually makes a lot of sense. And when it doesn't make sense and the part's not fitting, usually you did something a little bit wrong on your paper. Usually you don't leave the day like, man, I still don't know what went wrong with that measurement. Most of the time you look, you're like, oh, shoot, my cut sheet was wrong. I cut it wrong in the first place. It's friendly math. It's building and constructing math. And if it was that difficult that it would prohibit people from doing it, we wouldn't have as many dumb welders as we do. We wouldn't have pipe fitters. I love you. Love you all. Hope that helps. I tend to ramble. Don't be afraid. I hope that when people are asking, do you have to know math to be a welder, that they are not apprehensive about it at all. Once you get into industry, the math that you do have to use that is highly critical is really attainable for what I would consider to be like the average person. I don't find it any more complicated than a budget for the household. Like, what are you going to spend on groceries because you've got the rent or the mortgage and the utilities and the car repair or something due? You gotta mess with those numbers to make sure everything works out. When you're baking cookies, when you're making a meal, you have to like figure out if you have everything that you need to make this thing. Just try it. Just do it. Just do it and don't be afraid. Just do it and don't be afraid. You're not afraid. Just do it. You're doing it and you're not afraid.